We're doing a tree diagram without replacement with 6 red marbles and 3 white marbles, and 2 are selected without replacement.
Beautiful. And we did this in, how long did we say this question should take? Around about 10 minutes. Now that when you're doing this a question like this, if you're doing it a little bit less than 10 minutes, it gives you a bit more time to look over some of the other questions. So hopefully, if you wanted to try this question now, you could. This was from page 21 in your notes. Let's go. First of all, the most important thing when you get a question like this, I can't tell you whether your test is going to be with or without replacement. Without replacement, though, we're sort of saying here in bold, without replacement, it's very important because the probabilities are going to change. Now, you may be given a tree like this where you have to fill in the blanks. If you get the tree diagram correct, you're going to, in this case, there's a whole 8 marks. You might have 10 or more marks in one question. So it's really important that you get that tree diagram going. Now, it says without replacement. So first of all, we've got a total of 9 balls. So what we're going to do is, over here, we've got, that's going to be out of 9, and this is going to be out of 9. That's the probability of a red and a white. Now, we've got 6 red, and we've got 3 white. So let's do that. On our first, when we first pick out a ball, then that's what we have. We have 6 red and 3 white. Now, in the second one, though, because it's without replacement, we need to consider that no longer do we have 9 balls. We have 8 balls in there, and marbles or whatever it marbles. So we've got 8 marbles for all of them. Okay, so I'm going to just put a little over 8 here, over 8 and over 8. Now, if given that I've got now this path over here is that's for red and then red, and we can actually go and list all of the outcomes here. So if I have a tree diagram, if you have a 2 by 3, then that would be 8 outcomes. In this case, there's 4 outcomes. 2 times 2 is 4. Let's write out what those outcomes are. So we've got R and then R. We've got R and then W. We've got W and then R. And we've got W and then W. Now let's work out what the probabilities are. Well, before we do that, if I take out a red, there's no longer 6 anymore. There's 5 red. And the good thing is, if you work out what the red is, then we know that this branch of the tree has to add 2. What does that have to add 2? You can shout it out. What does this branch of the tree have to add 2? 8 out of 8. Yeah, so therefore that must mean that's 3. Now, if I take a white marble out and we've got 3, all of a sudden we've got 2. And if I've got 2 out of 8, then that means there must be 6. Okay, so let's get the tree diagram first. If you can get that done, there's a good portion. There's a lot of your marks, actually, because otherwise you're going to get consequentially wrong. Now, what's the probabilities? Well, we have to multiply them together. Now, do you need to go ahead and simplify fractions at this stage? I don't think you do. Okay, because we want the same denominator for all of them. So that is correct. It's 30 out of 72. So what's the next one? We've got 6 ninths times 3 eighths, which is 18 out of 72. Very good. And then the next one is 3 ninths times 6 eighths, which is the same, 18 out of 72. And remember, you have a calculator in your test as well, but you should be okay with those times tables, hopefully. If you have to put it into a calculator, it's going to take you some time. You could put it in correctly. So, of course, you do need to know your times tables. Now, the question is, when we get to this stage, are we right? Well, a good check would be that these all add to 1. So, or 72 out of 72. The question is, does 30 plus 18 plus 18 plus 6, what does that equal? Well, we've got 30 plus 36 is 66 plus 6 is 72. Yes, we've just checked that we've got all of those probabilities add to 72 out of 72. That's everything. So it's a pretty good idea that, yes, I'm correct. Now let's go ahead and find and do the rest. Find the probability of selecting at least one white marble. Now you can just write that in English, or we could say that, something like that. Okay. So how many of these are white? We've got at least one Well, there's 1, 2, 3. We're looking at these. Now I'm going to get a highlighter out, and so we're going to highlight this one, and this one. So we're simply just adding them all together. Now, as it turns out, the probability of that is going to be, we can say it's 18 out of 72 plus 18 out of 72 plus 6 out of 72, and that's going to be, what, 42 out of 72. Now, we definitely would need to simplify that fraction. You have a CAS calculator, it'll simplify the fraction for you, but that is the same as dividing both by 6 is 7 out of 12. Is that what we got? Yeah. Okay, 2 marbles of the same colour. So that's the same as the probability of getting white, and also the other way we can get it is if you get red, red. So let's add those together. Okay, I'd be okay if you just sort of had your answer there, but that's technically what we're doing. So the probability of red, red is 30 over 72, and the probability of white, white is 6 over 72. So therefore that's going to be 36 out of 72. Once again, if I divide both sides by 6, we could do that. That's 6 over 12. 6 over 12. How do I simplify that? That's going to be 1 over 2. Thank you. So please simplify it in the end, because otherwise you might be penalised half a mark, maybe once or twice. Yeah, half is the answer. Now, the probability of exactly one red marble. So exactly one red means that, well, this one has one red and this one has one red. So the probability of, we'll call it red is equal to 1, or you could just write it in English. That is perfectly fine. You're adding the two things together, which is just these two here, 18 plus 18. Once again, it's the same thing, 36 out of 72, which we're just going to write is a half. We've already been through that. Now, it's asking us here, it says that the experiment is repeated with replacement. Find the probability of selecting. So now what we've got to do is we've got to be very careful. If it's with replacement, the probabilities don't change. So that means we could do a little tree diagram if you wanted to. It might pay to. Just remember that those probabilities of red and white never change, because we're getting that marble and we're putting it back in the lot. So that's 6 out of 9. There's 3 out of 9 are white. And over here, that would be 6 out of 9 for red, and this would be 3 out of 9. 6 out of 9 again, and that's 3 out of 9. So now what we can do is have that in the background, and let's go and work out what is the probability of a white marble followed by a red marble. Well, that's going to be this guy over here, white, red. So the probability of that is 3/9 times 6/9, which is the same as 18 over 81. Now, once again, is there a number which goes into both of those? Well, yeah, there is actually. If I could divide both by, 9. 9 goes into 18 2 times, and 9 goes into 81 9 times. So there you go. The probability of a white then a red is 2 over 9. Your calculator will tell you that as well. 2 marbles of different colours. So 2 marbles of different colours means that, well, we've just found what white, red is. Well, why don't we go ahead and find what red, white is? Well, red, white is the same. We've got 6/9 times 3/9. In actual fact, that's exactly the same thing. That's going to be 2/9 as well. So the probability of 2 marbles being different colours, we need to add these two together. So that's going to be the probability of red, white, plus the probability of white and red, which is 2/9 plus 2/9. And remember that when we're adding two fractions of the same denominator, we don't add those together. We simply just add the numerator. So we've got 4/9. And finally, at least one white marble. Now, just quickly, if at least one white marble, what we can do is we've got red, red, and we've got white, white. Can I just say that here's a little hint, which is going to save you some time. At least one white marble. Well, this one contains at least one white marble. So does this. So does this. So rather than adding 3 things up, we know that all of this adds to 1. So why don't we work out what the probability of 0 white marbles are, or what's the probability of this, and subtract it from 1. And that means that rather than adding 3 things together, we can just subtracting it. Now, let's work out 6 nights times 6 nights is what, Ollie? 36 over 81. Very good. Now, so what we can then do is the probability of, I'm just going to write it in English, at least one white. Now, that is equal to, rather than adding up all of those things, 2 9s plus 2 9s, we can say we can subtract our 0 white marbles from 1, and that's going to give us our answer. Now, that's going to be the same as 81 over 81 minus 36 over 81, and of course, that gives us 45 over 81. Now, if you do that in your calculator, I know that 3 goes into both numbers, so 3 goes into both numbers makes that 15 over 27. Well, if we could divide it by 3 again, it would be 5 over 9. So we could divide that by 9, which is, so our answer, simplified, is 5 over 9. Now, I've just explained that, and of course, you don't need to explain it in your test. How long have we gone? It's gone for 11 minutes. But I reckon that if you could be aiming to do that in 5 or 6 minutes, we've explained the whole process. Do you need to write out all of this? No, you don't. But one thing I do suggest is that you do this check over here and that you see that they all add to 72. Because if they do, then there's a pretty fair chance that everything from there on, you're going to be using the right information. All right, I'm going to stop that video there, but I would advise to definitely study this style of question before you go and do your test.